All right, in this video, we are going to talk about the quadratic equation. If you recall, we've already talked about the quadratic equation before, but just to remind you, a quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, the number with x squared, is not equal to 0. If that number is 0, then basically this whole term gets wiped out and you're just back to a linear equation. So that's why the a has to be non-zero. Okay, so in a previous section, we talked about the principle of zero products, and then we used that to solve quadratic equations by factoring. Okay, and so that approach is you need to know that, and the issue with that is that it doesn't always work, right? And so what we're going to talk about in this video are some special forms of the quadratic, and these are I like to think of these as the easier cases of the quadratic, because well, you'll see when we work through the examples that you basically will just solve for the squared part of the equation, and then um, uh, take the square root of both sides. And so these are a little bit easier. There is one little catch in there, and we'll talk about that. All right, and then in the follow-up video to this one, we will talk about the quadratic formula, and the quadratic formula will solve every quadratic that you have. Okay. All right. So let's talk about these special cases of the quadratic. And so what you want to do in these special cases, these are pretty easy to spot because of the fact that there is no x term, right? If you look at the general form ax squared plus bx plus c, the bx part is missing. It just has the squared term, and it just has the term with no x in it, okay? So that's what these two are. And this one, if you multiplied it out, it would have the x term in there. But the main thing is, if you look outside of these outside of this parenthesis in this square right here, there's no x on the outside. So that's how you can kind of spot this case right here. Okay, so let's jump right into it and solve these out. Okay, so the first example is 6x squared minus 12 equals 0. So this is one of the special cases. And so what you want to do is, in these special cases where the x term is missing, is to solve for the x squared. So I would add 12 to both sides, and I'd get 6x squared equals 12. And then get the x squared by itself by dividing both sides by 6. Okay, so I get x squared equals 2. All right, so I've solved for the x squared term, and then the solution of that will be x equals plus or minus the square root of the other side over there. Once you solve for the x squared, so this is called the square root property. If I have x squared equals a number, right, then there are two solutions to that equation. X equals plus the square root of that number, x equals minus the square root of that number, okay? So it's the negative part that people forget a lot, okay? And that's it on this one. So you can see it's when you have a special quadratic like that, it can be a pretty quick process. We do need to make sure that the radical is reduced as much as we can get it, and this one certainly is. And so that's it on this one. Now the plus and minus notation, you're probably familiar with that, but just in case you aren't, right, that is just short for x equals square root 2 or x equals minus square root 2, right? Again, mathematicians like to write things, condense the writing that you have to do, and so this is just a short way of expressing this fact right here. Okay, let's move on to the next one. All right, in the next one, I have 3x minus 4 quantity squared equals negative 6. All right, so you can see that this is, again, one of the special types of quadratics that I showed you, right? And this is that third type. How you spot this one is you can look outside of this square, the thing that's being squared. If you look on the outside, there are no x's. All of the x's are inside this square. And so um, so this is one of the special cases, all right? And so essentially what you want to do is almost the exact same thing that we did last time, right? Last time we had x squared equals some number, right? And then we said if you have that, then x equals plus or minus the square root of that number on the other side. Okay? Well, same thing here. It's not as simple as x on the inside. The thing that's being squared is not just x, but it's more complicated than just x. But it follows this same principle. This just says, hey, if you have some stuff being squared and it equals a number, well, you're going to have two solutions. That thing that's being squared is plus or minus the root of the other side. So that's the same thing here. I have some stuff being squared. It's equal to this number, right? So that square root principle says that the stuff that's inside the square, 3x minus 4 in this case, is going to be equal to plus or minus the square root of negative 6. Okay? Okay, and so now what I need to do is to simplify this as much as possible. And hopefully you watched the previous video about simplifying complex numbers, right? Because right in that video what I said was when you encounter that negative sign underneath the square root, right, you immediately need to pull the negative 1 out, or the negative sign out, however you want to think of it, as the complex number I. All right, if that seems like a mystery to you, then go back and watch the video that I posted about complex numbers. Okay? All right, so you would want to reduce this radical as much as possible, and it is reduced, okay, as much as you can. Now, the thing is, we still would have to solve for x here, right? So there's still some things that we would have to do. So what we would do is use the addition principle, right? We would add 4 to both sides, and that will get us a little bit closer to having the x by itself on one side. Over on the left side, I have 3x, right? And then on the right-hand side, I have 4 plus or minus I times the square root 6, okay? Now, this cannot be combined, right? These two are not like terms. This 4, right, has no variable or anything like that in there and no roots, right? And so in order to combine it with this term, or to combine another term with this term over here, it would have to have both the I and the square root 6, and you can see the 4 does not have that. So you can't combine this any further over here. It is what it is, okay? All right, and then finally, to get the x by itself on one side, then I would divide both sides by 3, like so. So I get x equals 4 plus or minus I times square root 6 over 3. All right, and so that's it. That's the answer on this one. It cannot be reduced anymore at all. You cannot cancel out anything because you can't really factor anything out of the top and bottom to cancel out. Okay, and so that is the final answer. Now again, just you don't have to write it out as two different answers, but I'm just going to show you because a lot of times I find people don't understand really what the plus minus notation means, right? This is short for x equals 4 plus I times square root 6 over 3, or x is equal to 4 plus or minus, oops, sorry, not plus or minus, but minus in this one, I times the square root of 6 over 3. All right, so again, you don't have to do this, but just make sure that you understand that this notation up here is short for this. Okay. All right, next example is four t plus 1 quantity squared minus 3 equals 0. All right, so again, this is one of the examples where a special type of the quadratic, you can see that the variable t only occurs inside this parentheses, and there's no values of t out here, right? So that means that we can use this technique that I've been showing you for these special forms. So what we would do is get the squared part by itself on one side, and to do that we would add 3 to both sides. All right, so I have 4t plus 1 quantity squared equals 3, right? So just like we've been doing before, to solve for that, right, we can take the square root, or say 4t plus 1 would be equal to plus or minus the square root of 3, okay? Okay, so next up then is to solve for t. All right, so to do that, I would subtract 1, right, from both sides and get 4t equals minus 1 plus or minus square root 3. And remember, we want to get t, right, by itself on one side. So we're a little bit closer to that. And then what we would do is divide both sides by 4. All right, and so our final answer on this one is t equals minus 1 plus or minus the square root of 3 all over 4. Okay? And that is it. All right, and that is it for this video. In the next video, we will talk about how to solve a quadratic equation by using the quadratic formula.